How many number of atomic orbitals has been overlapped? That many number of molecular orbitals will form. Why molecular orbitals are polycentric? Because it will be influenced by two or more nucleus in the molecule. It is simple shape because atomic orbitals we know we are having simple shapes, but it is having complex shape. We are writing the electronic configuration of a molecule through the bonding molecular orbital and the anti-bonding molecular orbital. Then the following parameters we will understand. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up session 5 from the chapter Chemical Bonding and Molecular Structure. In the last session, we have discussed about the hybridization and various types of hybridization like sp3, sp2, sp hybridization, and also hybridization involving sp and d orbital like sp3d, sp3d2, sp3d3, like this various kinds of hybridization we have discussed. And also another type of bond, that is coordinate bond, we have already discussed. In this session, we are going to discuss about molecular orbital theory, energy level diagrams of molecular orbital theory, and the last type of bond, that is hydrogen bonding. Okay, in this session we will discuss these interesting topics and major topics for your examination also. First, we will discuss about molecular orbital theory. Hunt and Mulliken put forth the molecular orbital theory to explain relative bond strength and magnetic properties of the molecules. The main feature of the molecular orbital theory are as follows. Hunt and Mulliken, they are the scientists who put forth the theory of molecular orbital theory to understand the relative bond strength and the magnetic properties of the molecule also. These are the two major features of the molecules. We have to understand about its bond strength. On the concept of bond strength only, the stability of the molecule can be explained, and the magnetic property is also a major characteristics. To understand these two properties, they have put forth the molecular orbital theory. And what are the main features of molecular orbital theory are? Atomic orbitals of comparable energy and of proper orientation overlap to form molecular orbitals. From the atomic orbitals only molecular orbitals will form. Okay, atomic orbitals of having comparable energy. Okay, through that comparable energy in the proper orientation. Orientation means that maximum overlap will be, should possess, see here, this is a maximum overlap, and the orientation is s and s orbital. If p orbital is present like this, here also maximum overlap will seen. Like this, the overlap should be present for the to form the molecular orbitals. The number of molecular orbitals formed is equal to the number of atomic orbitals overlapping. How many number of atomic orbitals has been overlapped? That many number of molecular orbitals will form. That's why the number of molecular orbitals will be equal to number of atomic orbitals has been overlapped. That is one under the same for the calculation purpose. See here, this is the molecular orbital theory, that is the energy level diagram. This is sigma and this is sigma star, and here this is phi A and phi B. This is bonding orbital lower energy than that of atomic orbitals. This is anti-bonding orbitals higher energy than that of atomic orbitals. Okay, overall this is molecular orbitals through the atomic orbital. These are two atomic orbitals, it is forming molecular orbitals. This is ground state, this is excited stage. Here energy is getting to increase, it will excited here in the, that's why we are written here in the star phase. Okay, this is energy level diagram. Here, the overlapping atomic orbitals form two types of molecular orbitals, that is bonding molecular orbitals of lower energy and anti-bonding molecular orbitals of higher energy. How it will form means, how the bonding and anti-bonding will form. See here, we know that electrons will discuss as a wave formation. In the wave mechanics, electrons will be in a wave structure. This is the level. This is plus, minus, plus, minus, plus, minus, plus. And if it is phi A and this is phi B, how it will be present? Plus, minus, plus, minus, plus, minus, like this. The overlap, plus and plus, minus and minus, see, plus and plus, minus and minus, plus and plus, minus and minus. If it is like this, the same phase will be present, correct? Plus and plus, it will form same phase. So, on this concept, it will give the bonding molecular orbitals. Okay, it will be presenting or it will be overlapping on same phase. So, it will produce bonding molecular orbitals. If, see here, this is positive, this is negative, this is negative, this is positive, this is positive, this is negative, this is negative, this is positive. See here, the different end will be getting on the same phase, right? Then it is opposite phase, the different charges is present, opposite phase, this is having same phase, that's why bonding molecular orbital and more attraction will be present. Here, this is one phi A and phi B, to both waves with having opposite sign, it will form anti-bonding molecular theory. Okay, overall LCAO means linear combination of atomic orbitals will form here. Okay, this is bonding molecular orbital, this is anti-bonding molecular orbital, this will be having more attraction, this will be having less, this will be less attraction means the repulsion will be more. This is the meaning of the first point. Molecular orbitals are polycentric. Why molecular orbitals are polycentric? Because it will be influenced by two or more nucleus in the molecule. But the atomic orbitals are monocentric because it has been influenced by only one nucleus. So, it will be monocentric. The molecular orbitals are polycentric. Polycentric means an electron in molecular orbital is influenced by two or more nuclei depending on the number of atoms in a molecule. Molecule means number of atoms will be present. In the number of atoms, so many nucleus will be present. So, it will be influenced by two or more nucleus. So, it will be polycentric. Electrons are filled into various molecular orbitals in accordance with Pauli's exclusion principle, Hund's rule and Aufbau principle. These are the things we have discussed in the structure of atom chapter in the distribution of electrons, the Hund's rule, Aufbau's rule and the Pauli's exclusion principle. After one orbital, one single electron should be first filled and later it should be doubled with another electron. And after everything added up, the stability of the molecule is more important. These are the things we have seen in those principles. Those principles should follow in this concept also. That this concept is continuation of that structure of atom concept. The difference between atomic and molecular orbitals. As I told, atomic orbitals are monocentric, means in an atom single nucleus will be present. It will be influenced by only single atom. In the molecular orbital, in a molecular two or more atoms can be present. In each atom, each nucleus will be present. It will be influenced by many number of nucleus. It is less stable. It is more stable. It is simple shape because atomic orbitals we know we are having simple shapes, but it is having complex shape represented by s, p, d and f orbitals. This sigma bonding and anti-bonding molecular orbitals are represented by sigma and sigma star. Pi bonding and anti-bonding molecular orbitals are represented by pi and pi star. These orbitals we know s, p, d and f, but here the bonding will change sigma and sigma star, pi and pi star. These are the major difference between atomic and molecular orbitals, very much important. Next one, the formation of molecular orbitals by linear combination of atomic orbitals. I have told already how the bonding molecular orbital and anti-bonding molecular orbital will form. According to wave mechanics, atomic orbitals are considered as electron in waves are represented by wave function, that is phi. Molecular orbitals are formed by the linear combination of atomic orbitals in two ways. Molecular orbitals are formed by addition of wave function of atomic orbitals in the symmetric combination. Symmetric means plus with plus, minus with minus, again plus with plus. Okay. As well as subtraction of asymmetric combination means wave function of atomic orbitals. There is a symmetric combination as well as asymmetric combination also we can see. See here, mathematically combination of two atomic orbitals, that is phi A and phi B, is represented by sigma means phi A, that is A plus B, that is symmetric. Here asymmetric means it should subtract, that is the mathematical representation of previous sentences. Molecular orbitals formed by the addition of wave functions of atomic orbitals are known as bonding molecular orbitals. Addition of wave functions of atomic orbitals, it will form bonding molecular orbital, that is phi B, and the molecular orbitals formed by the subtraction of wave function of atomic orbitals is known as anti-bonding molecular orbitals. Here sigma will be present, here sigma star will be present. Addition of atomic orbitals increases the attractive force. Yes, this addition of atomic orbitals increases the attractive force while this will decreases the attractive force. Okay. Next one. What is the difference between bonding molecular orbitals and anti-bonding molecular orbitals? Formed by the addition of wave functions of atomic orbitals. This will formed by the subtraction of wave function of atomic orbitals, that is symmetric combination, this is asymmetric combination. Energy of bonding molecular orbitals is less than that of corresponding atomic orbitals. Here the energy of bonding is less, but energy of anti-bonding is more. Electrons in the bonding molecular orbitals increase the force of attraction. Yes, here the force of attraction is more between atoms and the bond formation to bond formation. Here it will, the energy is decreased for the bond formation. They do not contribute to bond formation. Just it will be energy form. Represented as sigma and pi, it will be sigma star and pi star. Next one. What are the conditions for the formation of molecular orbitals? To form a molecular orbitals by the atomic orbitals, there should be a presence of conditions. What are those? Combining atomic orbitals must have comparable energy. Okay, simply the atomic orbitals will not form our molecular orbitals. It should have 1s and 1s, 2s and 2s, like this only it will form. Comparable energy will be present, but not very much. Combining atomic orbitals must have the same symmetry around the molecular axis. It should have a symmetry around the molecular axis. Atomic orbitals must overlap to the maximum extent. How much means? If s orbital is present, the maximum overlap should be present. This is the overlapping region. If the maximum overlap is present, then it will form the maximum molecular orbitals. Okay. If it is less like this, the stability will also get less. Here the overlap is very less, not like this. That's what they are telling. Atomic orbitals must overlap to maximum extent. Next one, types of molecular orbitals. We know sigma molecular orbitals are present and pi molecular orbitals also present. Molecular orbitals formed by the addition of wave functions of atomic orbitals along the molecular axis are called sigma bonding molecular orbitals. When it will form by the addition of wave function. That is, sigma bonding will form by the addition of wave functions. Molecular orbitals formed by the subtraction of the wave functions of atomic orbitals along the molecular axis is sigma anti-bonding. Normal sigma bonding will form by the addition of wave function. Sigma anti-bonding will form by the subtraction of the wave function of atomic orbitals. In the pi molecular orbital, formed by the lateral overlap. Here, the axial overlap will be seen. Axillary overlap can be seen, but here the lateral overlap can be seen. Same thing, if the addition is taking place, that is normal pi overlapping. If the subtraction is taking place, that is pi star overlapping can be seen. Differences between sigma and pi molecular orbitals, it is formed by the axial overlap, means end to end overlap. This is lateral overlap of atomic orbitals. Here overlapping of atomic orbitals is maximum. Here overlapping of atomic orbital is partial. Next, energy level diagram of molecular orbitals. The order of increasing energy of various bonding and anti-bonding molecular orbitals formed by 1s, 2s and 2p atomic orbitals in case of homonuclear diatomic molecules of elements of second period is shown in the energy level diagram below. Means in the homoatomic means H2, Li2, like this. Same kind of atom should be present or molecules element should be present. See, this is a general energy level diagram. This is atomic number greater than 7 it is having. This is atomic number less than 7. Like C2, B2, everything. Okay. Less than 7, this is greater than 7. Like this. See here, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, 2pz. Next 2px equivalent to 2py. This is 2px, 2py. Next 2pz. But here if you see sigma 1s, sigma star 1s, next sigma 2s, sigma star 2s. But here at the place of sigma 2pz, the 2px will be equivalent to 2py. Okay. Here larger difference is, larger energy is present, here less. And here 2pz, next pi star 2px, pi star 2py, next sigma star 2pz. This is the major difference between more than the weight atomic mass number is 7, here less than atomic number 7. This difference you should know. Here sigma 2pz is present, at that same place pi 2px equal to pi 2py is present. Here small difference is present, here the large difference of energy is present. That's why this difference is seen. See, order of increasing energy of molecular orbitals in O2, F2 molecules. 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, next 2px, 2py, next 2py and 2px and 2py, that is 2px. Okay, this is the major difference I have shown. Here normal H2, He2, Li2 like that. 1s, sigma star 1s, 2s, 2s sigma star. In the place of 2px, it will be different here. Later 2pz, 2py, 2px and 2py, 2pz is present. Next, see here, significance of molecular orbital theory. If we are writing the energy level diagram or molecular orbital theory we are studying, means what are the significance? Based on the electronic configuration of a molecule, it is possible to predict the following parameters about a molecule. We are writing the electronic configuration of a molecule through the bonding molecular orbital and the anti-bonding molecular orbital. Then the following parameters we will understand. What are those? Bond order, stability of a molecule, the magnetism character, magnetic character, everything we will study. Bond order, it is 1/2 of the difference in the number of electrons in bonding orbitals and the anti-bonding orbitals. See, 1/2 of the bonding minus anti-bonding. That's why 1/2 into NB minus NA. This formula we'll use in next in bond, that is energy level diagram. Next, stability of a molecule. If the number of electrons in bonding molecular orbital is greater than number of anti-bonding molecular orbitals, then the molecule is stable. Means number of electrons in bonding molecular orbital should be more than number of electrons in anti-bonding molecular orbital. This tells that stability of a molecule. Next one, nature of bond and bond length. The bond length decreases with increase in the number of bonds between two atoms. The bond length decreases with the increase in number of bonds. Single bond means the bond length will be very high. Double bond means in the middle. Triple bond means the bond length will decrease. See here, bond length of single bond is more, bond length of double bond is in between, bond length of triple bond is very much least. That's why it is contradictory characters. Next, magnetic property of the molecule. If there are unpaired electrons in the molecule, then it is called paramagnetic. If all the electrons are paired, then it is called as diamagnetic. Okay, paramagnetic will be this one or like this, but diamagnetic will be present like this. Okay. Nature of bond refers to single or double or triple bond. Paramagnetic character of a molecule depends on the magnetic moment, number of unpaired electrons, that will be N. Greater the magnetic moment, greater is the paramagnetic character. If the number of unpaired electrons is much more, then the paramagnetic character will also more in the molecule. See here, to find out the magnetic moment, root of N into N plus 2, that is Bohr magneton, that formula will be used. N is nothing but number of unpaired electrons present in the molecule. Okay, see here, number of unpaired electrons. Next, bonding in some homonuclear diatomic molecule. Now we are moving to the energy level diagrams in homonuclear diatomic molecules. The bond order, stability and the magnetic character of a molecules of first and second period elements in the periodic table can be determined from the electronic configuration and molecular orbital energy level diagrams. Like homonuclear means H2, Li2, B2, C2, that is second period and first period elements they are telling. We will see now hydrogen molecule, that is H2. Total number of electrons in the molecule is 2. Okay, because two atoms are present, 2 electrons will be present. The electronic configuration sigma 1s2 sigma star, no electrons are present. So bond order half into Nb minus Na, bonding 2, anti-bonding 0. What will be present? 2 ones are 1 is present. There is a single bond between 2 hydrogen atoms in a hydrogen molecule. Molecule is stable and diamagnetic since all the electrons are paired. See here, in the molecular orbital, the electrons are paired in the molecular orbital. So no unpaired electron is present in both the molecular orbital. So it is diamagnetic and more stable molecule. Okay. Now helium molecule, atomic number is 2. The total number of electrons are 4. Right? If you write the electronic configuration, 1s2 sigma star 1s2. Then what will happen? Half into bond order will be half into Nb minus Na equal half into 2 minus 2, 0. The bond order is only not present, means the number of bonds. So the helium molecule does not exist since the bond order is 0. Helium and helium molecule will not form because the bond order is only 0. To understand, we can write both the things, but the bond order, since it is 0, the molecule only does not exist. Next, lithium molecule. The electronic configuration of lithium is 1s2 2s1 because 3 is atomic number, but the 6 electrons are present in lithium. So what is the electronic configuration? 1s2 sigma star 2s2 and 1s2 and 2s2. The above configuration is also written as in the K main level shell 2s2, where Kk represents the closed K shell structure 1s2 and sigma star 1s2. From the electronic configuration, lithium molecule, it is clear that there are 4 electrons present in bonding molecular orbitals and 2 electrons present in the anti-bonding molecular. Bond order is half into 4 minus 2, it will give 1. It means that lithium molecule is stable since it is no unpaired electrons will be present. Therefore, it must be diamagnetic. Diamagnetic lithium molecules are known to exist in a vapor phase. Okay. They are showing that lithium molecule is present in the form of diamagnetic nature because no unpaired electrons is present. See here, the bond order half into 4 minus 2 is 1. Lithium, one bond will be present. The molecular orbital configuration, the bond order and the magnetic character of beryllium 2 and boron 2 are indicated in the following table. Beryllium 2, 2s2 and sigma star 2s2, bond order 0. That molecule also does not exist. Boron 2 means 2s2, sigma star 2s2, 2px and 2py, that is 1, paramagnetic in nature. In the above molecular orbital configuration, Kk represents the bonding and anti-bonding molecular orbitals formed by the combination of 1s atomic orbitals. We are discussing about Kk shells, Kk main level shells, how it will be formed by the combination of 1s orbitals. From that it will form bonding and anti-bonding molecular orbitals. If the number of electrons in bonding and anti-bonding molecular orbitals is the same, then the molecular does not exist. Means, because we are subtracting here by this formula, half into Nb minus Na, correct? If bonding is 2 and anti-bonding is 2, what will happen? It will become 0. That's what they are telling. If the number of electrons in bonding and the anti-bonding molecule is the same, then that molecule does not exist because the bond order is not present. Next, we'll move on to carbon molecule. The electronic configuration of carbon is 1s2, 2s2, 2p6 because at atomic number 6, there are 12 electrons in C2. The electronic configuration is less than 7, that's why 1s2, sigma star, 1s2 and sigma 2s2, 2s2 and 2px equals 2py2. Overall, the bond order half into 8 minus 4, 2, and carbon must be diamagnetic. Diamagnetic carbon molecules have detected in vapor phase. It is important to note that both the bonds in carbon are pi bonds because of the presence of 4 electrons in 2 pi molecular orbitals. Means see here, due to this, it will form 2 pi bonds between this one, carbon. Okay. Double bond is made up of a sigma and a pi bond. One will be sigma and one will be pi. Next is nitrogen. It is having the atomic number 7. The electrons is 14. The electronic configuration, it will be 2py and 2pz. 2px and 2py is equal. Half into 10 minus 4 equal to 3. The molecule is highly stable because the bond order is 3 and the 2 nitrogen atoms are bonded by a triple bond. Like this, triple bond will be present. Here 2 pi bonds will be there, 1 sigma bond will be present. Since all the electrons are paired, molecule is diamagnetic. See here, this is the N2 molecule, 1s2, 1s2, sigma star 1s2, 2s2, sigma star 2s2. Here 2px and 2py equally present and 2pz is also already paired. Since it is paired, 14 electrons are there. That's why it is already completely filled in all the molecular orbitals. We can tell that this molecule is diamagnetic and it is highly stable. Next, oxygen molecule. Number of electrons is 8. Number of electrons in oxygen molecule is 16. The electronic configuration is written here, 2px, mainly pi 2px is pi 2py is present. Okay, the bond order half into Nb minus Na, that is 10 minus 6. How you have to find means, this is the bond number 2, 4, 6, 8 and 10 because whichever the presence of star is there, that is anti-bonding. Without star, that is bonding. Okay, that's why 10 electrons are present. Here 2, 4, 6 are present. That's why 6 here. This is equivalent, right? They have not considered. The molecule is stable as bond order is 2 and the 2 oxygen atoms are held by a double bond, 1 sigma and 1 pi bond. Usually the oxygen will be present like this. Since there are 2 unpaired electrons, the molecule is paramagnetic. We'll see where it is unpaired. See here, it is filled. It is also filled, completely filled. Here also, but here, see here, in the excited stage, 2px and 2py, it is having 2 unpaired electrons. Okay, if that unpaired electrons is there, n equal to 2, what is the formula? Bm, that is n into n plus 2, 2 into 2 plus 2, 4 2s are 8. Root of 8, whatever the result, that much of Bohr magneton will be present. This is about the overall energy level diagrams and all the concept of molecular orbital theory. So, by understanding this, you can write any kind of molecule if the bond order is having some definite number other than 0. We can know that molecule exist or not by understanding the electronic configuration of a molecule, and also what are the pi bonds and what are the sigma molecular orbitals also we can understand. Next, last but not the least concept, the types of bond. Still we have the last kind of bond, that is hydrogen bonding. How the hydrogen bond will form? In that, the two kinds of hydrogen bonds are present, that is intermolecular hydrogen bonding and intramolecular hydrogen bonding is present. So, how it will be formed, on what concept, on what basis it is present? It is electrostatic force of attraction between hydrogen atom which is covalently bonded to a high electronegative smaller atom like F, that is fluorine, oxygen or nitrogen atom of a polar covalent molecule. Means hydrogen atom will always covalently bonded with highly electronegative. Highly electronegative means it may be chlorine, it may be fluorine, it may be nitrogen, bromine, like this kind of atoms which is having smaller atom, it will be present, such as H2O, ammonia, HF, etc. That is, and the electronegative atom of either of the same molecule or other molecule, it is denoted by dotted lines. See here, dotted lines are present, right? This represents the hydrogen bond. The H atom acts as a bridge between two highly electronegative atoms. If two highly electronegative atom is present, it will act as a bridge in between. So, the types of hydrogen bonding is intermolecular hydrogen bonding and intramolecular hydrogen bonding. First, we will see intermolecular hydrogen bonding. If hydrogen bonding exists between two molecules of same or different substances, then it is called intermolecular hydrogen bonding. Hydrogen fluoride in solid state as well as liquid and gaseous state consists of long zigzag in liquid and chain of hydrogen fluoride molecules linked together through hydrogen bonds, whereas the gaseous state hydrogen fluoride consisting of small zigzag of hydrogen fluoride molecule. This is in liquid, this is in gaseous. Everywhere hydrogen is present, bridging between two highly electronegative atoms, see here also. But the difference is here long in liquid, here short in gaseous. Okay. And also the two different elements are present in between in the same or different substances. In water molecule, the central oxygen atom is covalently bonded of two hydrogen atoms, two or more hydrogen atoms of neighboring molecules through hydrogen bonds. Not only one oxygen is present between two hydrogen, for this oxygen, other hydrogen of other water molecule also can combine through hydrogen bonding. Due to intermolecular hydrogen bonding, the association of molecules takes place. Since energy is required to break the intermolecular hydrogen bonding, such compounds have high boiling point. If the hydrogen bonding is present in between the intermolecular substances, intermolecular hydrogen bonding is taking place between the substances means it needs high boiling point, because here the association of molecules in the substance is more. It needs high boiling point to break that molecule. Next one, intramolecular. If the hydrogen bonding exists within the molecule, if the within the molecule is taking place, that is intra. Between the molecules is taking place, that is called inter. Then it is called intramolecular hydrogen bonding. In this type of hydrogen bonding, a hydrogen bond is formed between a hydrogen atom that is covalently attached to more electronegative. It is little bit different. More electronegative present close to its same molecule. Okay. See here, this is more electronegative. This is also electronegative, but it is having less electron species here. Within the molecule, it has been taking place. The intramolecular hydrogen bonding decreases the possibility of association of a molecule to a large extent. Therefore, compounds with intramolecular hydrogen bonding have low boiling point. Due to intramolecular bonding, the association between the molecules is less, so it needs less boiling point. In the intermolecular hydrogen bonding, the association of molecules was very high. Due to that high boiling point was needed. This is about the hydrogen bonding and interhydrogen bonding and intrahydrogen bonding. It is based on more electronegative atom with hydrogen atom. This completes your chemical bonding and molecular structure chapter. I hope you have completely understood the chapter, what I have discussed from the all sessions. So, we will meet in the next new chapter or new topic. Thank you.